All right, and we're live. Welcome everyone to Xbox Series X Teardown. We're going to wait for a few more folks to just file in. While we're waiting here, we want to hear from you guys. Number one, down in the chat, make sure that the little blue bubble says that you're sending to everyone. So flip that over and then tell us where you're calling in from. And since we're talking video game consoles today, we would love to hear about your first, either the first video game console that you owned or the first memory that you have of playing one. So super excited to be joined by Chris and Riley here. Let's talk about our first video gaming interactions. Let's start with Riley.
Yeah, absolutely. So I'm not a big gamer, unfortunately, but I do have three older brothers. So my first video game experience was playing the GameCube, specifically Super Smash Brothers with my brothers, 5 years old. They were 15 and 18, and they would beat me a lot. But once in a while, I would beat them by just key smashing the entire time on Super Smash Brothers, which you can do, and you can win a game once in a while. So that's my claim to fame, is that I beat them when I was 5 with the GameCube.
Excellent. How about you, Chris?
Yeah, similar to Riley, I think I had a lot of older cousins that got the latest and greatest, and so we would play, I think, the Nintendo system, NES, and I remember eventually when they got tired of that system, they would pass it down. I got the hand-me-down version of all of these things, so I think I have a Nintendo system at home, or at my parents' home, but it was like 10 years after it had been released. How about you, Tobias?
Yeah, a couple distinct memories. The first one that I owned was the Sega Dreamcast, and I had great memories of that. I still fully believe that it was ahead of its time. The controller design, I think, kind of laid the path for a lot of the modern ones. But the most memorable one, thinking about teardowns, was the original Xbox, which I still actually have up in my attic, and the top is actually still only partially put back on, because some of you guys may remember we were talking about mod chips. So way back when, this was my first experience taking apart a console. I actually took it apart, bought this third-party mod chip off of somewhere on eBay, and you had to like scrape off a couple solder pads to install this chip that allows you to install all this third-party software. So good memories of both the Dreamcast and the Xbox. All right, welcome to everyone else. Let's kick this thing off. So welcome to Change Notice Unsnapped. This is our monthly teardown series. I think this is number 15. And we're switching it up this week. We're in the office. We're in the office, which is a sign of fun things to come here. So for everyone just dialing in, two things. One, chat in the bottom right. Switch that to message out to everyone so we can hear from you, and introduce yourself and tell us about the first gaming console that you owned or had an interaction with. So our goal here, again, we're building a community for knowledge sharing, support, and continuous improvement. And if you do need to duck out early, please fill out that survey, because that's how we pick what to tear down next. So with that, does the Game Boy count? Yes, that definitely counts. Maybe not a console, but definitely counts. Up front, just with all our teardowns here, we don't have any insider knowledge on this product. So this is just based on our past experience in electronics design. And with that, let's introduce the team here. Well, number one, Chris, our tried and true regular here. Looks like you're in a slightly different spot in the house. You want to tell us a little bit about that?
Yeah, actually, it's just the same room, it's just a different view, because my wife and I, we've had to consolidate offices because we are expecting a new member of the family soon. So this will probably be my last live one for a little while at least, but we're looking forward to that. And my background is mechanical design. Was at Amazon for a long time working on Kindles, and saw some of the like Alexa products come up. And most recently, I'm at a self-driving or autonomous tractor startup called Autonomy. And so still doing some mechanical stuff, very different in scale and size, but similar challenges with like how to fit everything into the same box. yeah, that's me. How about you, Riley?
Yeah. So hi, I'm Riley. I am a senior solutions architect here at Instrumental. My background, so I got my degree in mechanical engineering. And then before I was working at Instrumental, I was working at a components manufacturer. So I have a lot of experience in plastics and helping my previous customers make sure that all of their plastics components were well designed for manufacturing. And then since coming to Instrumental, I've consulted with, 15-ish customers, making sure that their products are, high quality moving forward. Yeah.
Right. Awesome. Super excited to have you on, Riley. And again, huge congratulations to Chris. He's been instrumental, no pun intended, core part of Team Teardown from the start here. And we wish him the best of his luck in his new adventure, and we're sure that he will be back in the future. And don't worry, everyone else, Team Teardown, we've actually have some exciting special guests in the coming months too. So great opportunity for the community here. I'm your host, Tobias, background in mechanical engineering, did product design back at Apple for a number of years, mostly on phones and watches. All right, so welcome back to all the regulars. See some familiar names here. Welcome back, Ron, and to the newcomers as well. So let's kick this thing off. So throughout the process, please post your questions. This is meant to be an open discussion. So questions in the chat, and let's get to it. Chris, you want to take us away?
Yeah, so let me share my screen here. This is the Xbox Series X. And it was released in 2020 in the middle of the pandemic, and I think they were facing some supply challenges at the time, and they think they may still be facing some supply challenges, or it's a hugely popular product. I think Amazon, you still need to get on some kind of invitation list just to get one. Luckily, we were able to snag a couple so we could do this teardown. I think it's actually quite large. I think it's about 6 inches by 6 inches by 12 inches. And it's quite heavy, so there's quite a bit of mass inside. You can see if I turn it around, there's a number of sort of holes for air intake and exhaust up here, and it's got this really cool like green accenting up there that we can take a look at later. I think, yeah, the other one, they actually make 2 different versions. There's the Xbox Series S as well, which doesn't come with a disk drive, but this one does, which is pretty interesting for 2022. But I think this means that it's backwards compatible, so you can put in any old games that you have, and so that's a really great feature that they've continued here. So yeah, I'm going to go ahead and get started here to open this up. I'm using. What I think is really cool is they basically use just one size screw or screw head, which is a T8. And there are 2 screws just to separate out this back cover. So I had to peel back this label here, and then you get 1 screw. And it's a nice green screw sticking with the Xbox green accent.
That's a good question. Do you think, what do you think is the purpose of those colored screws?
I think it kind of tells you, gives you an indication of which subsystem it is, but could also just be for fun. But yeah, these green screws tend to tie into the same system as, and we'll see a couple more of them later. So I got 2 screws here. Let's see. One thing with having a bunch of holes in the bottom of your product is you have places that you can attach things to. So I think there's a couple of hooks that I can get out if I'm careful. Put that so you can see it. Hook, and one more hook over here. This. There we go. So this is the cover. You got all the ports over here, and then this is the basic architecture inside. I'm going to take off one more piece, and then we might want to get a closer look through the platform But this one is pretty interesting because I think there is a little, let's see if I can get it. So this rubber foot actually rotates in place, but there's a lock. There you go. So I can take that part off,
Cool.
which is really neat. But yeah, so that's what we're seeing here. Got kind of the lay of the land, fan, disk drive, and main componentry. But yeah, maybe I'll switch it to Riley so she can take us through some more details here.
Yeah, absolutely. Chris, while I'm switching over, just a heads up that your video is a little bit laggy. So
Okay.
for those of you who have not seen Instrumental's app before, so Instrumental is a manufacturing optimization system. The goal of Instrumental is to help engineers get their products to market faster with a higher quality end product. What you're seeing right now is just the imaging portion of the application, and that's what we're going to be using for the rest of the teardown to get a deeper dive into some of these components. So this is the rubber foot that Chris was just talking about that we imaged earlier. You can see when we tore this down ourselves, this is the locking component that he was undoing earlier. So you can see it slides over top here and just locks into place in this part. And then all the tiny little hooks along the edge you can see here as well. I think the other thing we noticed when we were doing this was these dents on the top and bottom, and I wasn't quite sure what we thought these might be for. And typically with plastics, you don't want to add unnecessary thickness or thin plastic changes, wall thickness modifications, unless absolutely necessary. So I'm not sure, like, if anyone in the audience has any thoughts for where these could be coming from, or Tobias or Chris, anything you think might be the cause of them adding this design component into the foot.
That one's, yeah, that one puzzled me as well. I'd love to hear from the audience. My initial thought was somehow optimizing the mold flow for the injection molding tool, because my eyes gravitate towards the three lines that go out from the center, which I assume are the weld lines. But I can't think of a great reason why those indentations would actually help with the actual molding. So I'm not actually sure if it's that or if there's some other design intent. What do you think, Chris?
I think now that I'm looking at this, I can see a little bit more. There's these little raised areas on the bottom for some pretty cool locating features, just like another pin and slot. And I think maybe those are designed to clearance those because it rotates, so they have to make a little bit of a wider area as it rotates. But I'm just noticing that now.
Yeah, good call out, Miguel. Absolutely. Looks like it is a feature in the mating part on the bottom of the product. Awesome. Anything else? Yeah, these are the weld lines. With a plastic part this large, you're probably going to have to inject from all three corners, so you can see plastic flowing in from here. It's like rivers meeting together in the center. You can start to see where all those different plastic parts meet up. And then I think as Chris is doing some final stuff, we want to get a high level view of the interior of the product. So you can see here's the top view. We have our disk drive that we called out earlier. We have the fan, which is an enormous fan that seems to be doing a lot of work within the product, right? Huge emphasis on thermal thermals within this unit. And then finally, what I consider the main sub-assembly, which is where all the intelligence is stored right in the center. If I zoom in a little bit, you can actually see the two main boards right here that are stacked really neatly in the center of the product. Chris, Tobias, any comments on why we would put these boards right in the center of the product rather than putting them to the side or elsewhere within this housing?
Yeah, I was thinking about this. I mean, I think given how much they're concerned about thermals, it does seem like you don't want the hot surfaces to be right on the edge of the product. And so maybe this was a great way for them to isolate those components so they're touching the least amount of surfaces on the outside. The other thing, they get a nice centered port selection down the middle, so it's an aesthetic choice as well.
One other thing before we go back to Chris too is I was noticing on the tiny little foot here. Did you guys see that teeny tiny little hole back on the round foot on the exterior diameter?
No.
Any thoughts? So if you guys, yeah, if you pop over there,
Let's see.
Ooh.
This guy, right?
and that does go all the way through, right?
I think so. You can confirm
Yes.
for me, Chris. Yeah.
Yep. I can see through it.
Yeah, I wonder, any thoughts from the audience on what do you think that hole will be? Chris, maybe you can guide us where that
do
actually
some
goes up.
investigations.
Yeah.
Let's come back through this. Yeah, it is interesting because it's, it's like it's, I think there's like a rubbery part on this disc, which is, I think, so to help it for stability when it's in its upright position. But I don't know why it would need a hole. I can take a look a little bit more.
Let's go take a look. Yeah, maybe let's hop back to Chris to see what he's got to take out next.
All right.
David with the OG Atari Pong. Love it.
All right, so if I look up where that hole is kind of lined up, it looks like the only thing under here is actually like the disk drive. So let me try to pull that out. I've removed a couple of screws. And this.
Yeah. So Christina's hypothesizing some type of poka-yoke feature. I don't see it. Looking at the mating part on the bottom, the little raised parts do have some mating locating features, but the little hole doesn't look like it actually aligns to anything physical. But good thought. We'll have to keep looking.
So I do see a hole on the disk drive itself, which if I might rotate, yeah, I think if I imagine this was down here and this was there, that hole might line up kind of like this. So what could that hole be for? What do you think?
I have some ideas. Wait for it. Ooh,
There we go.
Two good guesses. My initial thought was also a reset, like Miguel said, but I think Andrew's actually right that it's actually the eject, the manual eject in case a disk ever gets stuck in there.
I haven't dealt with disk drives in so long that I've forgotten that was a problem.
Yeah.
Disks get stuck in there.
Yeah, I assume it's some kind of reset for the memory or a hard override.
So I took out the disk drive, and then I've got this pretty massive fan, as Riley alluded to earlier. I think it's like a 130 millimeter fan, and you can see it takes up like the entire height of the box and the width too. So it's basically all fan at the top, and then I think pretty much just have to take out these two flex connectors, and these are kind of interesting. They have a unique locking mechanism, which I'm not sure I'll be able to get on the screen, but this one you have to lift up a little flap, and then I'll just peel it back a little bit. But this one is interesting, and I have to push down on like a little spring lever. But you can see these both have like little locking tabs so that they won't come out, which is pretty neat. But once I release those and I've taken out the other components that unhook the disk drive, I can just lift out this entire assembly, and we can get a look at the box, which is, thinking about this, it's one of the ideal like sizes you just for mechanical packaging. You really just have as much room as possible in the physical volume of X, Y, and Z. But then thinking about it, it is actually a perfectly 90-degree six-sided box, which is very impressive. So that's might be something we want to take a look at later. But let's get to the guts first. Put this on the side. And what are we taking a look at here? So this is the view that we saw earlier. We got the rubber strap, this sort of sandwich of all the components. On this side, it looks like we got some power supply units, pretty beefy metal like shielding can, and a really interesting, this is like a solid cable routing clip or something. It's like a looks like a molded polypropylene or something, and it's like, big hefty snap in there to route the wires. So that's pretty interesting, and I kind of wonder why they did that. And then on the other side, you see this big metal heat sink. It's pretty tall, a lot of fins, and the air passes through as it goes up to the surface. We also got another board here. Looks like maybe some kind of communication board or a Wi-Fi board. But yeah, that's kind of the lay of the land here. Maybe.
Actually, it's really interesting to me because that clip for cable routing I've honestly never seen a plastic clip that large for cable routing. Tearing this apart, I mean, if you think about like from a cost perspective, that's not an inexpensive part to add. And oftentimes you can do something like cable routing with much smaller clips within an electronics product. Actually, if I can share my screen, Chris, I'm gonna accidentally raise my hand, apologies. You can see normally on something like a product like this that's quite large, you have cables everywhere within a product. This is a server example, but you have clips that control cable routing that are like this tiny, a tiny little polypropylene product. And this is a server, like this is an enormous product. And you get these tiny little clips for a very large cable. And if you go in, I mean, there is a portion of this that wonders if it's just better for actually controlling cable routing if you have it fully controlled all the way through. Because if I look at this region and I'm looking for something that looks anomalous around the clip itself, there's a lot of variation that can happen with a clip this small, with cables this long. So you can see here, this can obviously cause problems if, between mechanical components like sandwiching each other. But I can also kind of speak to, difficulties in actual performance of the product. And I think, Tobias, you said you had an issue with one of our customers before with something similar like this.
Yeah, this actually reminds me, there's two very common issues that I see. One is rub and buzz with any type of cable that's not fully constrained, and also has, either some acoustic design. Actually, rub and buzz becomes a huge issue if the cable isn't clipped in properly. The second one is actually antenna performance, which isn't always affected by cable routing, but there was one specific customer that was having a bunch of antenna failures and actually used instrumental to correlate those failures to the exact position of the cable. It wasn't even unclipped. It was just the position that the cable was, which would be a crazy hard conclusion to come to without this type of data set. Right. So cable routing may seem simple, but lots of consequences if you don't do it right.
Yeah, absolutely. Well, I'm thinking about it. Let me bring up our product again. Apologies, I'll give me a second. This is what happens.
Hop back in. It looks like, Chris, you're going in parallel there, which is great.
Yeah, there's a lot of screws out here. So I'm going to take off some of these so you don't have to watch me just unscrewing them.
Yeah, absolutely. So as we dive in, here's our beautiful cable clip. Guys, I'm still obsessed with it. I think my favorite part of this teardown is this clip, as well as this this rubber piece. So I think Tobias, you said earlier, with cabling, right, there's rub and buzz. With a piece of rubber this large, I would assume it's going to control for something similar. I'm not sure what the audience thinks of this, enormous rubber component.
My best guess is, again, with the fan and the disk drive, as well as the expected lifespan. I don't know if we touched on that, but these devices, again, you buy this for many, many years and it gets a lot of use. Again, a lot of mobile products. Again, you do reliability testing for, maybe three to 5 years, but these, a lot of them are expected to last much, much longer. And so robust solutions like this I think to prevent, again, any type of noise or loosening of screws from vibration over time.
Yeah, Absolutely. We got a question from Ron asking if we can tell what's being routed through that cable guide. And the answer is yes, it is power. You can see it's coming out of the power block here through the cable, right through here. So again, that rub and buzz that we're talking about. And I think the larger theme that I'm kind of hearing as we're talking this through is this is, an incredibly powerful product, right? Like there's a lot of computing that's happening on here because it's so powerful. There's a lot happening. It gets really, really hot. So, okay, first thing we got to do, control for heat. What they do is they add a lot of thermal components. They add a big fan, and a fan introduces a lot of vibration. And the worst thing you can do is just vibrate your components pretty constantly. So a lot of this seems to be trying to minimize that. Some of that that could happen within the product.
Riley,
Yeah, for sure.
I see a few what looks like foams to the south side of that cable, but also up around there. Tell us what you think those are.
Oh man, I would assume some sort of shielding, right? In this component. I mean, Chris, I'm not sure if you can tell me if we know where this is connected to within the final product.
Yeah, well, I think those cables that you're looking at right above it are for the disk drive. So I think the disk drive actually slides past that foam and then maybe that cable clip right below it and that other piece of foam. So maybe maybe they were worried about that power being disconnected when you're inserting the disk drive. So let's just create a flat surface there. And then for the foams, yeah, you're kind of having this large metal piece and you want to ground it. And maybe insulated as well from some of that vibration we're talking about.
Exactly.
Excellent. All right. Well, Chris, how are we looking on your side? I know there's a bunch.
I think I did get out quite a few of the screws. So let me share my screen again. So, and I'll say that some of these screws are actually quite difficult to disassemble. I was like kind of wrenching on them quite a bit. And if I look, there's actually, you can see some thread lock on these. And these are some of the long ones that go on the corner. So I think this is kind of holding the large sandwich together. But let me see if I can get some of these other components out first. So there's a mixture of these screws. Again, they're all using that T8. And there's like another clip here, which just kind of goes on the outside. And I did have to, one other thing, I had to remove this, we mentioned this earlier, this sort of antenna board. One fun thing is when you look at antennas, you can see where the actual antenna is, just because it's like completely evacuated of copper, of solder mask, of everything else. So that's where the actual antenna is. You can kind of see the pattern there. So I think this is like one of the Wi-Fi antennas. So I had to remove that. But once I did that, did I get all the screws up? There's 2 screws here.
Ron had an interesting observation on the cable routing as well, that sometimes these power cables require some secondary insulation to control for the emissions, either the radiated or the conducted. So that's really interesting, because I think a lot of the cable routing examples aren't always power cables. So that may have played into the decision to go above and beyond on that cable enclosure there.
They heat staked it in, y'all. Like I'm still on it. I'm gonna be on it for the rest of this teardown. They heat staked it in. Like, crazy.
Yeah, it's really impressive that they've gone to a lot of lengths to make sure that cable clip does not come out. I forgot, I have to remove this strap.
Yeah.
There you go. I got this screw, this screw, this screw. I got one.
Yeah, there are a lot of screws on this main this main sandwich, I think is what we're calling it.
Yeah.
You were talking again earlier, I think, about how all of these screws are trying to just keep this as tightly together as possible. Probably again for the same 2 themes that we are hearing, which is thermal and rub and buzz vibration.
See, the rubber strap is still attached to here. There we go. Okay. Oh, I got the other cable clip that I have to take apart now. We have a second one.
There's a lot of different connector types on here as well. There's a lot of more standard ones, but we should take a look later. Chris, when you were talking about before that interesting metal connector, I believe those are all ZIF cables, right?
Which parts? On the inside, yes, those are the two. These are the ZIF connectors here. Yes.
Yeah, those first ones that you took off, they were ZIF connectors.
Yep.
But they had, it looks almost like a completely metal enclosure for that ZIF receptacle, which I haven't seen before. And again, we've taken apart a lot of devices. We've seen different ZIFs, vertical ZIFs. We've seen ZIFs with the little wings to fully lock it in. Why do you think they went with this type of ZIF design here?
That's a good question. I think just for the way that it's assembled, since these are going to the accessory boards at the outside, sort of the last stage of assembly, I think they might have needed something like they could get a very small amount of travel, and they could use some tools and not damage. Because let's say you assembled everything, then you go and install those cables and you break the little plastic clip that comes off. They probably wanted something a little bit more robust so that it would allow them to have a little bit of flexibility for those for the workers in the factory. I've still got, I think, a few more screws to take off here, but you can see the underpinnings of the main board, or one of the boards here. Looks like we got another antenna board, and I can kind of see some of the different antenna patterns on this again bare board over there. But as I take this part off,
yeah, Ron made an interesting point, is that there are some really cool sheet metal parts within this assembly.
There are.
Yeah, I mean, I think you see the one that the cable guide is staked to, like he said, very deep draw, which is really true. I mean, something like this, when it's being stamped, which is what I'm assuming is happening here, the tooling for this, like the design for a part like this, is really difficult. It's not super easy to design a part to be stamped at scale with this kind of deep draw. And it looks like all of it is in service of shielding, is what I'm kind of assuming. Tobias, Chris, would love your thoughts. Similar along the same lines as me?
Yeah, I think there could be a couple reasons here. And again, yeah, robust, very above and beyond robust designs, both in the shielding, the cable routing. And again, I'm excited to look at the molding of the giant enclosure as well. So I'm kind of noticing a theme here. The shielding, yeah, looks like a lot of attention paid to the grounding of the perimeter of this, and then the conductive foams to make sure the disk drive is grounded. So yeah, I'm thinking shielding of either components on this main board, on the board behind it, is probably the intention, but making it extremely robust like that, I think was a conscious design decision.
Yeah, I would also say I think they probably are thinking about like heat transfer. I mean, this is maybe protecting, because this was sitting underneath like the power supply, so they wanted to make sure that some safety from the power supply, but also some thermal componentry or thermal considerations as well. But yes, going back to Riley, your earlier point, the deep draw. This is a very deep draw, and it's not easy to get that right, just because sometimes when you pound those things together, you might get a break in the corner, or you might see sharp edges, and they intentionally wanted to avoid sharp edges because of all the cable routing, like this ribbon cable here, or some of these other components that if anything did vibrate loose, you could wear and tear and eat into, like that power cable, for example. So I think that was something that they were very conscious about, and didn't go with like just a standard stamped and folded shield, but actually with these drawn components.
Yeah,
that's an interesting point on the thermals too, because you can see the exterior of that plate it looks like it's intentionally making contact with exposed copper all around the perimeter, which again could be to dissipate heat from the PCB up into the shields, could also be grounding, though it doesn't look like there's any specific foams between there, but it's likely not needed with that direct contact. So thermals and shielding.
Yeah. And then this is the main, or one, not the main board, but one of the boards here. And actually this, which kind of fun, this is like another that Wi-Fi antenna board, and it just kind of, it has a way so you can slide it in and out if you want to just replace this part without removing the entire assembly, because this shield was covering this part. Another couple of really interesting mechanical points I'm seeing, there's a lot of different pins and slots in this board, and we might be able to take a closer look at them, but like I see, just so I can turn them a little bit, you can see these pins are standing quite proud. There's a pin, there's a slot at an angle here, so that kind of lines up with this one, so that tells me that this is the locating feature for this main board. And then these are like clearance holes, which means that's a locating feature for maybe some other componentry that comes on. So a really cool use of different pins and slots into this giant, massive, I don't know if it's a casting or something else that they use for the main heat sink on this board. But yeah, maybe we can go into the platform, Riley, to take a closer look at some of these components, and I can continue to take some of these things off.
Absolutely. Let me go ahead and make sure I got the right thing pulled up. Just a moment. Yeah.
Yeah, we're looking at, you've got the full sandwich, and there's one board on one side and one board on the other, right? Oh yeah, here we are.
Yeah. So you can see here are the sandwich boards right in here. So here's that power supply we were talking about earlier. Here's another that Wi-Fi board that we think is a Wi-Fi board. And then that same pin and slot, there are a couple of really strong themes during this teardown, and one of them seems to be the pin and slot. It looks like this is used to datum the part in a way, quote unquote, datum the part in a way inside the housing. Is that what it looks like, Chris, to you, Chris?
Yeah, I think so. These are like keyed, which means that this, I think, is like designed to slide down, and then there are two pins actually at the bottom. So I think this slides and keeps it located in sort of one plane, and then it goes and smashes into the bottom of the plastic housing, which then locates it in the other two directions, which is pretty cool. So you get a little bit of slide travel, and then you can remove this, like we showed earlier, you could just pull the whole thing out.
Right, exactly. I mean, I think you can also see on a separate point, you asked about like, oh, I think it's most likely like, oh, is this a cast part? I would say yes, most likely a cast part. You can see that almost, my gut is saying pretty clearly from this view, and that it looks like there's some, raw cast finish on the side here, and then some post machine components, obviously, for this datuming feature.
Yeah.
Pretty clearly in here. Oh yeah, exactly, Ron. So that happens a lot when you're doing, so Ron made a comment that the keyhole slots are CNC'd. That's post-processing that happens on a lot of, I'm assuming aluminum cast parts, just to make sure, especially if it's like a nice finish. Obviously this isn't a nice finish, but it's a lot easier for them to just take the part out, fixture it, and CNC those really, really quickly, rather than trying to create a tool for a cast part that's going to have like side action features within the casting itself.
It's also pretty neat to see that there's probably some flashing or something that was coming through, and they just machined that all off so that you don't get any sharp burrs, again, as we were talking about, avoiding the sharp components on this.
Right, exactly. Not quite as easy to control molten aluminum, in my opinion, as plastic. Yes. So you got to do that post processing a little bit more. Awesome. Anything you want to show us, Chris? Do you want me to give it back over?
I can. I was able to take the sandwich off, and then maybe we can dive in one more time to the platform. Right. So I was able to take this final sandwich part apart. So we had the other board that kind of sat on top here. And then this one, and inside you get this giant X, and a bunch of thermal paste around in different locations. You can see some here, that I think sat over there, and yeah, this is the main. This looks like probably the main board that we're looking for, that the Microsoft team was trying to dissipate all of the heat from, just because you got this giant clip. And the other side of that is right where that heatsink goes. So
Pretty awesome. Yeah, I'm looking at that, and I wonder if it reminds me of the teardown that you guys did before. What was that? Was it the Max?
Oh, the Mac
the Mac
Studio. Yeah, we should take a look at that one, because this is that is a monster, what looks like a Spring X clip there.
Yeah.
Good luck, Chris, taking that off without
It's the best of
having it
all.
spring away.
I'm gonna do one side, maybe. I'll see.
Let's see. Internal, I think it was the internal tops. You can see it's the same kind of idea. You can see this has like the fins actively on the board around this, the X component is what I'm calling it. And it looks like it's doing that same thing you were talking about before. We're trying to press it even closer, right, Tobias?
Yeah, so what we had talked about before, this one's interesting on the Mac Studio, because the processing unit's actually on the other side, same with the Xbox here. So this spring is, we think, is ensuring pressure on the back side to ensure contact of that processing unit with the heat sink on the other side. These fins here, this is like a bonus heat sink on this side of the PCB, which is interesting. But yeah, if you look at the Xbox one and we look at this giant spring clip, what else do we see on this board here if we take a deeper dive?
Yeah, so you can see the spring clip. And then the other thing I noticed is actually all of these like solder pads that are soldered to nothing. It looks like it just filling in the space here. I'm not quite sure what you guys think is going on in these areas around the edges here.
Yeah, that's pretty fascinating. It looks like a shield can, and I think when we were doing some research on this, we looked at the iFixit teardown from right when this came out in 2020, and there was a shield can. It had a nice X pattern that went over it. But as you can see here, when we took this apart, there was no shield anymore. So maybe a cost down opportunity for Microsoft. Just you don't need another piece of metal and then another. And if you're shielding that, then you also need to do that sort of like a post process, or need to install this clip beforehand. So probably save some time in the operating in the factory.
I always like to see when devices like this, they're still implementing optimizations and improvements even in mass production, because not all companies do that. Some people say, you know what, it's good to go, nothing's wrong with it, let's leave it alone. But it was clear here that they still did some sort of analysis to determine that this could be optimized. And yeah, I agree. I think that must have been the old shield can there. And we see this in some other devices as well, some no stuffed components that it'll be better to just leave the PCB design the same, but leave the pads and just cover them up with some solder there. I see a lot of what I'm assuming is thermal paste around here. What are those covering, those three big pads?
These are shields. I think we have a breakdown. Chris, I'm not sure if you can see on your side what those are covering.
I think the bottom one's a connector, which that's actually a new one for me. Like, yeah, you commonly see the thermal pads over some of the components, especially on the processing units. But this, Chris, can you tell, is that the main video connector that they're worried about thermals on there, which is why they put that paste?
I think actually these two are related. This is I'm just reading the back of the box. Here says it's a storage expansion. So I think it comes with like 1 terabyte of memory or storage, and I think you can insert your own like a proprietary secondary card if you have a lot of games or a lot of information that you want to store. So maybe it's like that rapid transfer of data that kind of heats up rapidly. And so I think this one for sure is that. I can probably take a quick look, or you guys might have already done it, but I pop this shield cover off.
Oh, underneath there. Yeah, Riley can probably.
Yeah.
Did you do that one? Yeah, there you go.
Look at that.
That. Looks like, I think we actually took out this component. Tobias, what was this again? Was this the actual memory?
I think that's the 1 terabyte hard drive that we have in there, which again, to Chris's point, that actually makes much more sense that slot is for the memory, and that's why they needed heat dissipation rather than just a typical maybe like data transfer on something else. So what about, the thermal paste here is again another common theme that we're seeing is like intense focus on thermal management. I know we see that with a ton of our customers as well. Riley, maybe if you want to share a little bit on that.
Yeah, absolutely. So I actually had a customer who was planning on using us just to control thermal paste at one point. We were really, really concerned about how it was being piped onto their component with a lot of our larger customers. But you can see here, even just like something like a thermal pad, which is obviously cut to size, right? Which is just, you just stick it and place it. When I'm doing something like an anomaly search on the product, there can be just a lot of variation with a pretty standard process. If you start thinking about when it's a paste, which is, getting closer to a liquid, there's a lot less control that you have over where that is going and if it's staying in the right location. I mean, you can see like the variation on just something that's like a simple place it down component versus something like the thermal paste we saw on the Xbox, right?
Yeah, this again, to me, this looks like again, manual assembly damage, or somebody forgot to place it on, or it got damaged, somewhere through the process, which unfortunately happens a lot. And the specific scenario that I remember with, I think it was one of our consumer electronics customers, a webcam-like device, and they were having failures at the burn-in, again, end of the line. They had a burn-in step. And when they were doing their failure analysis, again, they took a couple of them apart, but in instrumental, they were able to correlate in large batches that the 2% of parts that were failing at burn-in, they just went back and it automatically identified. It wasn't quite this severe looking at this. Like, it's pretty obvious, but it was a dispense pattern that was not quite ideal. And again, they didn't have any visual check in place to verify the dispense pattern. It was kind of a blob. So that was a really big impact for them. It looks like Joel's asking how it works. Maybe you can show just a preview.
Yeah, just really quick. I mean, while we're here, so something like this, we could ingest test data, and so customer could put in like their burn-in test within the system, and then with 2 clicks on that final test, asking the system, hey, show me visual correlations between units that are failing and what's causing this issue. So this would be burn-in, and then it would most likely bring up a couple areas around the thermal paste, is how our system would find something like this. But yeah, looks like the Xbox team did a pretty awesome job trying to control for that with how that thermal paste is dispensed right now.
Excellent. Thanks, Riley. And again, for all those out there, we're getting close to the end of our time here. So if you have any questions, specific components you want to make sure we touch on, we still need to look at the housing, that massive molded housing, and get to that last side of the PCB here. But Chris, what are we looking at?
Yeah, so this is that spring that we were looking at earlier. And you can see how much force is required to torque this down, because normally it's down, and I've unscrewed this one side all the way up, and it's bending back the opposite way, which means that they're putting a lot of force on this, and they're trying to balance it so that it stays in there. But yeah, I'm gonna take this apart carefully because I do want to see what's on the other side. Oh, there we go. Okay.
I think the one comment I will make from when Tobias and I were tearing this down ourselves is I had to have I think Tobias, you had to unscrew this for me because it was torqued down so tightly that I couldn't do it. And I held down the PCB while we were doing it because I was genuinely afraid that it was going to fly up into my face, which how tightly this was torqued down. So I'm impressed, Chris, that you're doing this live on camera for us.
Yeah, I probably should have done it a little bit at a time in every corner to release the tension, but you know, I wanted to show you guys how much was on one particular side. So now I'm going to do the other three kind of more a few twists at a time.
That's the safe way to do it.
Probably less fun for the viewers, quote unquote.
Less fun for the viewers, yeah. But you know, I think my future child probably would like to have a parent with two eyes would help.
For the family.
Possibly, quite possibly.
Yeah.
Pretty impressive. All right, let's.
Okay, I think we're almost there.
And then underneath, does the X spring connect and contact directly to the PCB, or I almost see a couple black tabs sticking out there.
Yeah, it looks like there's a plastic thing that's actually, I don't know if it's heat staked in or glued in here to this one.
Yeah, almost.
There we go. So it's just like a frame that transfers the force into these four sort of broader plastic tabs, I think, that are just molded on to this.
Yeah.
But once I take that off, I believe, let's see, does this separate? Yeah, I feel like there must be some more thermal paste in here.
Yeah,
there we go.
We've got the monster heat sink on the other side.
So I think this is the chip. It's got its own thermal paste there. A bunch of, looks like the memory chips are on the perimeter of that.
Ooh.
And then we've got a pretty impressive heat sink here, which has the letters VPR, which I think says vapor chamber. So yeah, I think they're definitely trying to conduct the heat away from this chip for sure.
Absolutely. Something that's interesting to me is that it looks like there's different thermal paste used around the component versus actually on the chip.
Yeah. Yeah, that's a good point. I wonder if like there's a compromise for the ones around the perimeter,
right?
Just to make sure that they can leave these dollops here and have it so they stay in place and not move too much, versus where you want a really smaller area but like a more tightly controlled flow of that thermal paste. But you can see it's still kind of seeped out around the edges and kind of got into some of the other components here.
Yeah. Awesome.
Chris, tell us a little. This reminds me back of when we were talking about the Nintendo Switch, which also had, again, an intense focus on thermal management and a much smaller space there. And we were talking about the different types of heat dissipation, different types of heat sinks. And we were discussing, you said the VPR there implies that this is some sort of vapor chamber. I know some people are very familiar with different types of heat sinks, but again, when I look at just the bulk of the heat sink is just these fins. Tell us what you think the vapor chamber portion of this is.
Well, I think actually a lot of these like these copper heat pipes that we've seen in some of the other components, I think are a smaller version of this. So you might have a single pipe where there's like a liquid that goes in, and then it when it heats up, it might vaporize and then kind of shift to one side, and then it will cool, and in that cooling it kind of releases some energy, so then it can kind of come back into this area as well. Whereas this is like I think this entire area might have some pathway for the liquid to go, just so it can disperse that heat across the entire heat sink. Because I don't know if you can kind of see this center area is raised, and there's like a little port here, which is probably how they filled this chamber to begin with. and then there might be some design path inside that we can't see. And unfortunately, I don't think I can take this apart without getting out the soldering gun or like a bandsaw or something to look inside.
Vapor chamber teardown coming next month.
But they're definitely trying to dissipate the heat from here and spread it so that it can go more evenly across these fins. And then that air, this giant fan that we saw earlier, is pulling all of that heat away to get that convective heat transfer. But yeah, that's.
I think you're right there. It's a combination. I think there's a small chamber there in the middle, which then spreads the heat to the fins. And Andrew made an interesting point here on the blue thermal gel is more of a gap filler, whereas the gray has higher thermal performance, is what I'm implying there. And that actually does remind me, we were having a discussion a couple months back about thermal pads versus thermal pastes, different viscosities. And I think the conclusion that we came to was there's a trade-off on how much gap you want to fill versus the thermal performance. And so I'm thinking what they're optimizing for here is a very, very small gap in that center processing unit. And that's sort of the datum feature where they want the maximum thermal performance. So they have a different thermal paste there. And then the blue ones probably less ideal thermal performance, but more easily able to take up that large gap. That's I guess that's what's going on here.
An interesting comment from Marco about like the blue could also just be die cut, right? Where like that could just be pop, 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 if necessary, right? Something that's like that thick.
Yeah, that makes sense.
More of a pad versus the paste.
Yeah. And I can definitely see the outline of where the hard edges of the chips are. There's kind of this sharp edges. Whereas on the thermal paste, you can kind of see the end of it, but it's kind of flowed a little bit more. So it's probably a little bit more viscous or less viscous. I think there's a couple of other questions coming through, but one thing I wanted to get back to was this giant plastic molded piece, because it is kind of a marvel in terms of how it was constructed. And if I look inside, I see some wording here, and I think mine says this is cavity actually 142. So that means they probably had at least 142 of these tools to make all of the X boxes in the world. So, there might be some supply issues, but they are pumping these out because you have at least several 100,000 of these parts that come off of each tool, multiplied by at least 142. And this was, purchased a couple of weeks ago. So they might have made a lot. But just in the way this is built, normally you have sort of the core and the cavity of a component, a tool that the plastic flows around. So you just have one side and then the other side. But to do that, you need to have significant draft angles, 2, 3, 5 degrees. Whereas this one, if you have a completely flat side, or even in this case, like a kind of a recess here, you need to have slides or moving parts of the tools, which makes the tools much more complicated. I think Riley, you had some experience with this or know what it takes to do that.
Yeah, sorry, I put a little heart up earlier because I'm just so impressed by a tool like this is no joke. Like when no company just does this for fun is what I will say. To be like, oh, why not make it 90 degrees everywhere? Why not have side actions on three sides? I think
it's all 4 sides probably.
All 4, all of these sides have side actions, and side actions meaning you have to have movement sideways in a tool, whereas before it's mostly like cavity and then other side of the tool coming in. Ron, I don't think there's any draft on the inside. I think it is straight, which means that the inside of the tool came in and then moved. Like there's sliding that happens as the tool goes in to expand into these spaces to create undercuts, to create these, these side features. I kind of want to annotate on the screen, but you can see this is crazy. This is like exactly collapsing cores. So this is hundreds of thousands of dollars. like to make like one of these. Like I am just so impressed. I love this. And again, this is like in service to the design, like visually how it looks, as well as some internal components that require the collapsing cores. But the exterior, like that is dedication to the 90-degree angles, the look, the feel of the product. And that curve there, I'm in love with it. It's one of the most beautiful pieces of plastic I've seen. Which is, kind of silly. Shows you what my background's in. But it's all of it, is crazy. And only a company like, Xbox for a product like the Xbox is something where you could do this, right? A casual housing component, you are not going to do this on every old, apologies. You're not going to do this on every single product. You're going to do it on the Xbox, right?
Yeah, totally echoing what Riley is saying. And you can see that each side actually does have some component that needs to be pulled from the outside. So like this slot, for instance, for the and then these holes for these different components. On this side, you have all the holes that come in for the airflow, and obviously on the other side to make that recess. And then you have this just very small little like Xbox logo. It is recessed into the side. And obviously this side, they needed to go into the middle. And on here, they have these holes just for these little rubber feet. So every side needed to have something that came from the outside. And you can actually kind of feel a little bit the parting line on the outside. But it is a very impressive piece of plastic. So
we didn't even get to talk about the Master Chief inside.
Oh, that's right.
I wonder if you can see that.
Here we go. Yeah. So on the fan, they have that custom logo there.
That is an intricate, small little design there. You think they did that? You think they did that in the mold, or was there post-processing?
Oh goodness, I hope it was in the mold.
I think it was. I suspect it was in the mold. You can see this like sharp line here, so they definitely were pulling something this way, this way, so they could get that for free essentially. But yeah, I think they would just kind of do a high polish and then maybe a little bit of etching down to get the raised Master Chief logo in there.
Yeah, I'm telling you, plastics, man. There is so much design that goes into it. These people are artists. Just really impressed with the whole Enclosure design here.
All right, we are just almost at time. Love all the discussion on molding. Maybe we'll get just a completely independent molding design 101 taught by the one and only Riley Hayes. It's a whole different realm there. Thank you everyone for joining. A few important wrap-up notes. First and foremost, huge thanks to Chris over the last 15 teardowns. It's been a blast. Enjoy the time with your family over the next coming months, and we will have a welcome back party for your teardown. We've got some exciting teardowns coming up next month, November, I think 17th. We're doing the new MacBook Air, so we're going to be dropping some links in. Please sign up there. Survey, again, we pick all these devices based on your input, so click that survey link and let us know what you want to see next. So again, thank you to everyone joining in. Love to hear your comments and commentary. And thank you to Team Teardown here. We will see you guys next month.
Awesome.
Take care.
Manufacturing has changed, and hitting yield targets, deadlines, and quality goals is harder than ever. Instrumental is the first manufacturing optimization platform designed to help both engineering and operations teams ramp successfully on every program by finding and fixing issues at the source and making sure they don't come back. From development through mass production, Instrumental is helping the world's most innovative brands and contract manufacturers accelerate failure analysis and drive continuous improvement by easily unifying their product data into one secure cloud-based hub. And you can get started in less than 1 week. Using images, video, machine parameters, functional tests, measurements, supplier and return center data, Instrumental makes collecting data and finding correlations easy. Our AI surfaces the most meaningful relationships among your data sets, so you can find the root cause fast. Starting with your first build, Instrumental proactively identifies new issues by scanning your products for anomalies in visual or functional test data and automatically delivering net new discoveries. In development, engineers can jumpstart failure analysis with defects in context by leveraging a rich, remote data set. With Instrumental, they can quickly identify correlations and potential root causes, and even push live tests to validate solutions immediately, eliminating issues at the source. In mass production, you can monitor throughout, get alerted of shifts, and identify correlations to root cause, unexpected drift, redundant tests, and operator issues. When installed across factories in a supply chain, brands and suppliers are able to stop working against each other and start working together to solve their most complex issues. Better products start with better data. Better products start with Instrumental. Schedule a demo today.